Welcome to a lesson with Dr. Powell. Let's take a look at some terminology that pops up in algebra. The first big one is expressions and equations. The two are different. So what is an expression? Well, it's just an idea that's expressed, but without an equal sign. It's a numerical idea, a numerical thought, such as x squared plus the square root of y. That's an expression. Even the number 1, just a number, 0, or, but something complicated, the square root of 2 to the cosine of x all over 5, x plus 1. Something like this, a numerical idea with different numerical operations going on. These are expressions. Now, within an expression itself, there are things called terms. Let's look at this first expression. There's two terms. That's a term, that's a term. Now, in this expression, for all sakes and purposes, I might just call this one big term. But inside, in the denominator right here, there's actually two terms in the denominator itself. The denominator was thought of as an expression, 5x and 1. So what is a term? A term is a chunk or an island that usually can be added to something else. So like 5x squared plus 3x plus x to the 7th. All right? These are all terms, and they're separated by pluses, or it could be minuses. So they're different parts of an expression are called terms. Often we think of terms being separated out that way. So that's an expression, terms. Now, an equation now is something that has an equal sign in it. You're relating two expressions together. Now when we're doing that, we could have something like x plus y is equal to 1. This is an equation. Some equations are less restrictive than others. And what do they even mean? I mean, an equation itself is a statement that one expression is equal to the other. This statement could be true, it could be false. It depends on which values that x and y take on. So an equation can be thought of as a true-false statement depending on which values of x and y work. Now, the graph of an equation with an x and y, so a graph, is actually a plot of all ordered pairs. So for instance, you could do, like in this particular case, you could do 2 and -1. That's an option, but there's lots of other ones, right? Or a half and a half. These are just different things. But a graph is all x, y coordinates that actually make the equation statement a true one. Okay, so an equation is something that could be true or false depending on what your values that you're plugging in actually are. So we have expressions, terms, equations. Next, we have the idea of simplify and solve. People misuse the word solve all the time. They say solving when they're just simplifying. Solving means you're finding values for a variable or a pair of variables that make an equation true. You could completely solve it by determining all such solutions, or partially solve it by finding just one or two of them. Simplify means something else. You're not finding a value that would make an equation true. If you're finding a value that makes an equation true, that is an acceptable use of the word solve. Anything else, probably not, often not. Simplify means we're taking an expression and we're rewriting it in maybe a form that looks a little simpler. Like, for instance, here's an expression, 2 plus 1 squared. it is what it is. We're not solving for anything, it's just what it is. We can simplify it or rewrite it, but really it is what it is. It's 2 plus 1 quantity squared. But we can, of course, rewrite it. 2 plus 1, another way of writing 2 plus 1 is 3. I mean, people often say, 2 plus 1, what is 2 plus 1? Well, 2 plus 1 is just 2 plus 1. It is what it is. But we can rewrite it. Another form of writing 2 plus 1 is 3. Then what do you do with it? Then so this is the same as 3 squared. Okay, what's another way of writing 3 squared? 9. We didn't solve for anything. All we did was simplify the expression, rewrote it in terms of another form. But really, that was it. Now, let's take a look at solving for a minute, and just think about that idea. There's a couple different types of solving that you could have. A number of them. I'm just going to go over briefly a couple common ones. The first one is something like this. Square root of quantity, x plus 2, then we have a minus 1, that's all over 5, that's equal to 3. Okay, so the first way of solving is using the idea of isolating. You want to isolate x, so put x by itself somehow in the equation. Solving is nothing more than rewriting your equation again and again and again in a simpler way. So you could even kind of think you're simplifying but an equation. But what you're doing is you're assuming that this statement is true, because it's an equation, right, is a statement of truth or falsity. So assuming that this is true, then what else is true? Or what is equivalently, what is an equivalent way of writing the statement about the truth and false, where the same values of x that satisfy this equation will also satisfy the new equation that I write down. And hopefully the new equation that I write down is a simpler one. So solving means going through that simplification of the equation process until we get something like x equals something. Now, if you get x equals something and you're trying to do that, that's called isolating. We want to isolate x alone. We can do this in steps. First of all, we can kind of think, what's the biggest thing that's happening here is division by 5. And so in your mind, you can think something divided by 5 is 3. What divided by 5 is 3? And you just think of simple questions like that a few times, you actually get the result. You don't even have to know algebra to do that. I mean, sometimes having intuition is nice. So here, something divided by 5 is 3. 15, right? Well, that means that this thing up here is equal to 15. So then you think, okay, this thing right here is equal to 15, right? So, okay, so now go to on this side. What's the next biggest thing that's happening? Subtraction by 1. So what minus 1 is 15? Well, that'd be 16. Oh, so that means this part is equal to 16. Then you think, okay, something square rooted is 16. What square root? And so you can kind of keep going in that manner. So something square rooted is 16, well, that would be 16 squared, right? So that means the inside right here is actually going to be equal to 16 squared. So x plus 2 is equal to 16 squared. All right, then you think, okay, something plus 2, what plus 2 is equal to 16 squared? Well, just 2 less than that. So x is equal to 16 squared minus 2. But notice, in this process, we could have rewritten that in algebraic steps, but the exact same idea. The first thing was we basically undid the operation division by 5. We multiplied both sides by 5 to get equal to 15. So we had an idea and we said, okay, what divided by 5 is 3? Well, that's like undoing division by 5, right? Undoing division by 5 means multiplying by 5, so it's like multiplying 5 to both sides. So really you're just doing this, you're keeping the equation the same, because multiplication by 5 on both sides does not change which values of x actually work. Square root of quantity x plus 2 minus 1 is equal to 15. Then you can add 1 to both sides. Great. You can square both sides. is equal to 16 squared, and we can even compute what 16 squared is, which should be 256. All right, and then you can subtract 2, and you get 254. Okay, so we successfully work through that process. Of course, kind of keeping this, we're going to assume, okay, so assuming now, of course, you know, we've made, okay, yeah, so that's good. Okay, so x is equal to 254. We'll just explain that. So that's our example of isolating. All right, so so we have isolating, but another way of solving an equation is simply another example. I'll just kind of put this down at the bottom. Is if we have something like x squared plus 4x minus 7. I guess this is another example of isolating. What we could do is we could think of x squared plus 4x. There's actually a squared chunk that's almost equal to that. If you know how things square with a FOIL, like if you have x plus something, whatever this is, like the middle term when you FOIL this out is always going to be double because the inside and the outside of the FOIL are going to be the same. So this is actually just 2 because we take 1/2 of this 4, so double the 2 will be 4. Okay, so 4x in particular, 2 times x times 2 would be 4x. But this is too much because, I mean, if we multiply this out, we're not going to get this, we're going to get something else. So kind of in this process of replacing this, we've actually added by something as well. We've added by a plus 4 because when we multiply this out, we're going to get x squared plus 4x plus 4. 2 times 2 is 4. So we have to add 4 to both sides then if we make that replacement. But notice the beauty of what we just did. We just made, so we had multiple x's appearing in the equation. We made one x appear. So we made one x appear, and then we keep going. Can add 7 to both sides. We get 11 is equal to x plus 2 quantity squared. You can square root both sides with a plus or minus, because when you square root, there's 2 different square roots that are possible. And then we end up getting, okay, so we square root both sides with plus or minus, we get x plus 2. So x is equal to negative 2 plus or minus square root of 11. Great. So that's actually isolating. So we have this idea that we can isolate when we solve. We can do that by just making sure there's one x if we had more of them. Or we could do something like that. I mean, we could have also done something like this. We could have had like, 5x plus 2x is equal to 6, and then we're thinking, okay, well, we have 2 x's. How do we isolate x? Well, factoring. We can factor out a common x. 5 plus 2 is equal to 6. So 7x. So notice we make 1x. We only want 1x when we're isolating. We don't want multiple x's. So the first step is to make sure we only have one of the guys. So x is equal to 6/7. All right. So when we're solving, we can isolate. But another way of solving is to turn our equation that we have into multiple simpler equations. So for instance, what if we had an equation that was already in factored form, like x plus 1, 2x minus 1, and negative x plus 2, all right, is equal to 0. That's an equation. Now, if you have things multiplied together to be 0, the only way that could possibly happen is if one of the things were 0. So either this guy is 0, or that guy is 0, or that guy is 0. So now you have simpler equations to solve, and in each one of these, you could isolate in order to solve it. But so putting 0 on one side is often a nice technique, especially if you can factor something like that. Ideally, also, what if you were able to get a fraction like x plus 1, x minus 2, all over something? It doesn't matter what it is, maybe even x plus 5, equal to 0. An equation is equal to 0 with a fraction on one side, and that actually reduces to the numerator being equal to 0, because when is a fraction equal to 0? specifically when the numerator is equal to 0. The denominator, nah, sorry. We just need to make sure that the x value that we get on the top to make 0 isn't something that's going to cause a 0 in the denominator. That's the only thing. We just have to check to make sure we didn't, make it's actually going to make this side make sense. So that's basically it for the terminology that I was going over. So we talked about expressions, equations, terms, isolating, and solving and simplifying. We solve equations, but we simplify expressions. Thanks for watching.